Hello and welcome to our presentation on the Fenerbahce CPU project. In this video, we are going to talk about how a CPU is made and what is the purpose of the project, going in some details about each one of them and also some tools that we are going to use to test it. So, starting things off. What is even a central processing unit, or for short, CPU? So, a CPU is a cornerstone of a computer that takes and executes commands depending on the instruction given by computer programs, and serve as the link between them. How the CPU works is by performing arithmetic and logic operations that manage data storage and retrieval and the input and output of operation with instructions from computer programs. It has different architectures such as complex instruction set computing or reduced instruction set computing that determine the CPU processes. It has a clock speed that is measured in hertz that affects the speed of the execution. Now, after we understood what is a CPU, we move on to block RAM module. The BLARM is a simple block RAM module that has the capabilities to read and write. It includes parameters for size, depth, and test case. It has input and output ports for clock, reset, write enable, address, input and output data that make a CPU function. It has a memory array that stores data. The always block is triggered on the positive edge of the clock that read and write operations based on the input. The initial block changes the memory based on the chosen test case. Now we move on to the FPU-CPU module. The FPU-CPU module represents a simple microprocessor with an instruction set. It has a parameter for address width and data width. It has register and state machines that control the operation. As shown in the code, the module has input and output ports for clock, reset, memory data in, RAM write enable, memory address, memory data out, and program counter. The always block is triggered on the positive edge of the clock and updates internal register based on the next state value. And based on the current state, the combinational block performs default assignments and manage the reset condition. Now, what is a test bench? A test bench initializes the system, select the test case, checks the memory content after execution, and terminates the simulation. The specific behavior of the test bench depends on the chosen test case and the functionality of the microprocessor and memory module. Now, for our test bench module, the TBFPD CPU module, the test bench for the microprocessor. It includes a parameter for test case, address width, and data width. The module has input and output ports for clock, reset, memory address to RAM, memory. And finally, we are going to talk about the project scope and what is the purpose of it. Our design consists of a simple CPU and memory module that then the test bench verifies the functionality of these modules by executing different test cases. The top-level module, aka top, initiates the test bench module that starts the program. In the end, we would like to thank our team for making this video possible. And also, thank you for watching.